This video will be an introduction to elimination reactions. For elimination reactions, we have E2 and E1. For E2 reactions, there are going to be tertiary, secondary, or primary alkyl halides. And for E1, we are only going to have tertiary alkyl halides. Just like SN2, E2 is also a concerted reaction where there's only one step, and for E1, there's going to be a slow and a fast step. For E2, a strong base and a strong nucleophile will be favored, and for E1, a weak base and weak nucleophile will be favored. For both E2 and E1, good leaving groups are going to be the weakest bases or the strongest acids. And both are going to form E and Z isomers because we're forming alkenes. And the most stable out of the two will be formed. Typically that will be E, because that will be trans. However, with E2, if you have sterics, you will get the opposite. You will get the least stable. For E2, we are not forming carbocations. However, with E1, we are. And typically for E2, charged species will help facilitate E2. With E1, we have neutral species. For both E2 and E1, this is going to be tertiary alkyl halides, along with all allylic and benzylic halides, but they must have a beta hydrogen on an sp3 carbon. Now the difference between SN2 and E2 is with a primary alkyl halide, you will get SN2. However, if you have sterics involved, you will get E2. For secondary, you're going to get both SN2 and E2. However, with SN2, if you use a small and weak base and a small and good nucleophile and a polar aprotic solvent, you can make more SN2 product. If you want to make more E2 product, you would want a strong and bulky base, a weak or bulky nucleophile, and a polar protic solvent at high temperatures. If the conditions are SN2 or E2 and you have a tertiary alkyl halide, you will only get E2. If we look at SN1 and E1, neither will form with primary or secondary alkyl halides. However, with tertiary, you will get both. If you want more SN1, you want a good nucleophile at low temperatures, and for E1, you want a poor nucleophile at high temperatures. That concludes the introduction video to elimination reactions.